So, in our first two class periods in pre-algebra in chapter 11, we have dealt with radicals, which involves square roots. We have done, including yesterday on Tuesday, we did equations with square roots, or really radical equations, which means you have an x that's a part of what's called the radicand, which is just an x under the square root symbol, is all that means. Well, today we're going to do something. I think you guys will like this because I actually believe it's probably easier than what we've been doing. We're going to actually work with the inverse operation, and what we're going to be doing is solving equations not with radicals, which are square roots, but solving equations with exponents, and all with which we're going to be dealing is squares, numbers that are squared, and actually it's going to be variables that are squared. And the way that we're going to get rid of those squares when it's all said and done is we're going to apply the square root, which will dissolve that square. Because remember, a square root is the inverse or the opposite of a square. And I think you guys will like too that it's not going to take very long. I mean, it's going to be a really short class today. And I feel like you guys deserve that. You should be rewarded because you worked hard. And also you're learning something that is really challenging to you right now. And I'm proud of you that you're putting the work in and that you're not looking at it and say, I give up. No, you're going to figure it out. And I trust that you have, and I know that you'll continue to do so. You guys are sharp kids. Okay, so here's what we're going to do. Let's start really easy. Number one, equations with exponents. If I have x squared, which I do, equals 16, I need to solve, guys, not for x squared, but I need to solve just for x. In other words, x to the first power, and we don't write that 1 above as a power just because it's understood. Every number, every term is. And so I need to get to x to the first power, or just x, but right now I have x to the second power. So how do I get rid of a square? Well, remember, to get rid of, quote unquote, something in math, and in particular in algebra, if it's being added, you have to do the opposite and subtract. If it's being subtracted, you have to do the opposite and add. If it's being multiplied, you have to do the opposite and divide. If it's being divided, you have to do the opposite and multiply. We've just found in our first couple of sessions in this chapter that if it's being, quote unquote, square rooted, for lack of a better way of putting it, you have to square it. Well, what do I do if it's being squared? I do the opposite, which is what? I square root it. I square root both sides. And I do both sides because whatever you do to one side, you always have to do to the other. And the whole purpose of doing this to the x squared is that's going to drop the squared part and just leave me with x because I've done an inverse operation. And guys, so in this one, it's so easy. These are one-step equations, these first two. All I have to do to solve for x is just square root the number 16. You might be asking yourself, oh, how in the world do I do that? Hey, we've been doing that for the last two class periods, and so it's really not going to be that difficult. And all we need to do is ask ourselves, what product of 16 that when multiplied by itself gives me that original number of 16? What product or what factor is there of 16 if I multiply it by itself gives me the number 16? That is the number BO. 4 times 4 equals 16. Therefore, the square root of 16 is simply the number 4. Although there is one thing that I do want to show you. When you're doing the square root of something, you must add this to it. I know this is going to look silly, but just do it. Do a plus sign, and then below it a minus sign, and then your answer in numerical form. And what that means is, the answer is either plus 4 or positive 4, or it's minus or a negative 4. And here's why. When you plug it back in and answer, and we're not going to do this with each one, but just to give you an example, so hopefully it'll make mathematical sense to you. Whenever you're checking an answer, and you can plug it back into your original equation, watch. If I put what I found for x, for it to be back into the original equation, and so I have 4x squared, so it's going to be, instead of x, I found it to be 4, so it's going to be 4 squared equals 16. That's my original equation. What is 4 squared? Or remember, that's not 4 times 2. Okay, that would be 8. That's not what that means. 4 squared, or raised to the second power, means 4 times itself, or 4 times 4. And 4 times 4 is 16. And does 16 equal 16? Bingo. And so I'm good on that one. But here's the thing. Here's the catch. I want us to do another number, and it's the other one that we put here. I want us for x to plug in not just a positive 4, but now I want us to plug in a negative 4, square it, and let's see if that's a true statement. Guys, what is negative 4, not times 2, but negative 4 raised to the second power, or times itself? What is negative 4 times negative 4? Well, 4 times 4 is 16, and if you have a negative multiplied by a negative, that makes what kind of number? A positive number, and so it's a positive 16. Does positive 16 equal positive 16? So you see both of these answers, a positive 4 and a negative 4, check out as potentially correct answers. And that's why when you're taking the square root of something to get rid of a square, your answer always has to be in plus or minus form, because either one of those is mathematically true. And so this is a unique thing to the square root, but just be aware of that and use it in all of these answers when we're applying the square root to numbers. Okay, let's do that with number 2. This isn't too hard, right? This one's just as easy really as number 1, and we're not even going to go back and check this one because we understand the principle now. But we have x squared equals 49. I don't want to solve x squared. That does me no good. I have to solve for x. That is x to the first power. And so how do I get rid of a square? I do the inverse or the opposite operation to that. I apply the square root, but I can't just do that to the left side of the equal sign. I equally must do the same whatever I do to the right side of the equal sign. And neither one of those is a division symbol. Both of those are square root. They look similar, but they're totally different processes. The reason for my doing that is it gets rid of the square that's attached to my x. And so now I'm going to have an answer for x after I apply the square root in its fullness to 49. But before I even deal with the numbers, what have I learned? If I apply the square roots, whenever I do that, I must put the plus on the upper half of the line and the minus on the lower half of the line. I'm just going to go ahead and do that so I don't forget. Now I can forget about it and just work with numbers. Okay, what's the square root of 49? And what's meant by that is what product of 49 that when multiplied only by itself, the exact same number, will get me to my original term of 49. What would that be? Okay, well, sorry, I'm a little anal when it comes to things like that. How about the number 7? Guys, what's 7 times itself? 7 times 7? 7 times 7 is 49. Therefore, the square root of 49 is 7. But it has to be plus or minus 7 because either one is equally true. Not too difficult, right? Well, let's move on to number 3. Instead of just one-step equations, now I'm going to do, with these final 3 actually, 2-step equations. And I have x squared minus 4 minus 3. In a 2-step equation, everything I know is wrong, and so I start in the simplest place first, which is in addition or subtraction. I need to isolate or get my x value all by itself on one side. We're comfortable with it being on the left side, so we're just going to leave it there. And what I do to accomplish that endeavor is this negative 4, I have to do the opposite, or minus 4 if you prefer. I have to do the opposite operation of minus 4. And what would that be? I add 4. I'm going to add 4 to both sides, because what I do to one, I have to do to the other, and the whole purpose of doing that is to eliminate the minus 4 from the left side. Now my x variable is all by itself, even though it still has that pesky squared attached to it, with which I must deal in a moment, but not right now. First, I need to simplify. What is negative 3 plus 4? Negative 3 plus 4 is a positive 1. I can't solve, though, for x squared. I must solve just for x, or x to the first power. And so how do I get rid of that silly squared that I do not want to be there? I must do the opposite operation, and the opposite of a square is taking the square root of a term. And what I do to one side, I have to do to the other. And so that square root gets rid of my square, being the inverse or reverse operation. And now all I have to do is find out what is the square root of 1, and I have myself an answer. But before I do that, guys, what signs do I need to write before I even start working with the number? I need to put in the top part of the line positive or a plus, and I need to put in the bottom part of the line a negative or a minus, because either one will be equally true because of the definition of the square root. Okay, what is the square root of 1? In other words, what number, if I multiply only by itself, will get me to a positive 1? I love squaring 1 and taking the square root of 1. You know why? Because it's always just 1. It just remains and you don't have to do anything. Because 1 times 1 gets you to 1. And that's the square root of 1. If you're trying to square 1, 1 times 1 is still 1. So you see, it doesn't really matter what you do, square root, square 1, it's just going to stay at 1. But what is important is because you took the square root, it's going to be a positive or a negative 1. Either is equally true. So let us now work on numero quattro. And what we're going to do with 3x squared minus 14 equals 18, two-step equation, well, technically it's actually going to end up being a 3-step equation, but these throw us off in that. It's what looks like, that's what's important really, it's what looks like a 2-step equation to us, and so everything we know is wrong. I want to start with addition or subtraction, and because of that I have a minus 12 being applied, or being subtracted from a 3x squared. So how do I move a minus 12 from the left side to the right side? I do the opposite operation. And since 12 is being subtracted on the left side, I'm going to add it to both sides so that I can get it to the right, which is really where I want it, so that my variable is closer now to being isolated. And that with which I'm left is 3x squared equals, what is 18 plus 12? That's a pretty simple one. That's going to be the numeral 30. And so I have 3x squared equals 30. Now remember, really I still have, I know it gets confusing because that was technically a 3-step equation, but it almost operates like a 2-step. And technically I still have a 2-step equation right here. And so everything I know is wrong, meaning I would rather deal with multiplication or division than I would squares, exponents and square roots, which would be similar to parentheses, but I want to deal with those first because everything I still know is wrong. Well, in order to do that, how is that 3 attached to the x squared? It is attached via multiplication. There's an invisible dot multiplying that 3 and that x squared together. And so how do I undo, guys, multiplication? I divide. And I divide both sides by 3. That gets rid of my 3 on the left side. I'm going to write over here because I'm running out of room down here. That gives me x squared on the left side. And on the right side, what is 30 divided by 3? 3 divided by 3 is 1, and 0 divided by 3 is 0. So x squared equals 10. Now, I need to solve for x, not for x squared. And so I do the opposite of the inverse operation. And the way I do that is take the square root of both sides. And when I take the square root of x squared, that drops that squared to an x. Beautiful. That's what I need. And over here, what number times itself gets me to a positive 10? Let me think here. 3 times 3 is 9. Okay, that's not 10. What's the next number above that, above 3? That's 4. 4 times 4 is 16. Whoa, wait just a minute here. There is no number that gets me to a perfect square involving the square root of 10. And so because of that, guys, you're going to like this. Don't forget your plus and your plus or your minus. You're going to love this because it's not a perfect square, 10. I don't have to go any further than that. I just keep it at plus or minus. Hey, you figure out, smart guy, what the square root of 10 is. And that's good. That's my answer. And that'll be counted correct. That's the way, the official way that it's taught. Okay, number 5. One more and we're done. See, short lesson. I told you, not too bad today, huh? Reward you guys for your hard work. X squared plus 21 equals 12. All right, I have a true two-step equation, and so truly everything I know is wrong. I want to do addition or subtraction first, get the x variable as much by itself as I can without doing the final step. And so to do that, I have a 21 that's being added. How do I move that plus 21 to the right side? I do the opposite of addition, which of course is subtraction. And so I subtract 21, not from one side, but from both sides. What you do to one side, you have to do to the other. And that leaves me with x squared equals, what is 12 minus 21? 12 minus 21. When you have opposite signs, that's a positive, that's a negative. You subtract the smaller from the larger. And so that means 21 minus 12, okay? It's going to become an 11, that's going to become a 1. And so 11 minus 2 is not 8. You awake? Not 8. Now, I know you guys can tell me what's right. And that's 9, but then I look back, the larger number had what sign attached to it? And so I attach that negative sign to that 9. So I have x squared equals negative 9. And I actually pulled a little bit of a boo-boo there. Didn't leave myself a lot of space, and so I'm going to Bob Ross it, which you probably don't understand what that means. But I'm going to write it over here, give me a little space. The reason for that, I have an x squared. How do I get rid of that squared? I have to square root that side, but what I do to that side, I have to do to that side. And so I'm going to square root both sides, which gets me where I want to be. X equals, oh, wait a minute. I'm taking the square root of a negative number, meaning that negative sign is found underneath what's called that radicand, or underneath that square root symbol. Do you guys remember from yesterday an important rule I taught you? If you ever come across a negative sign underneath, now if it's outside, that's a whole different ballgame. But when a negative sign's underneath a square root symbol, that is a no-no. You can never do that and come up with a true answer. And that is because no number times itself, whether positive or negative, will ever be a negative, because a positive times a positive has to be a positive, and a negative times a negative has to be a positive as well. So that can never be a true statement. So if at any point in a problem you're doing, you get right there in that spot where there's a negative sign underneath a square root and an x over here saying it's equal to that, you say, oh no sir, or oh no ma'am, it is not. You put you a big fat 0, you draw you a diagonal line through it, and you circle it, you stick a fork in it, and you say, I'm done, because you are, and you have the correct answer. That is no solution. You cannot have, as a square rooted number, a negative. Cannot be the case. That's all I have, guys. And like I said, I'm proud of you. Keep up the hard work. I hope you do feel slightly rewarded with a little lighter math load today. And also what I feel like, I hope you'd say the same, is maybe even an easier lesson than what we've been doing up to this point. Just keep on keeping on, guys. There's light at the end of the tunnel. I'm proud of you, and I believe in you. and we're going to have math class no more today. Not until tomorrow on Thursday. I'll see you then.